So let's start with the tactile simulation. If you have a coin, that's great. If you don't, totally fine. I already flipped the coin because I didn't want it landing and annoying everyone as I flipped it 8 times. But take a coin, remember it's 50-50. And with Sarah, she either gets the problem right or she gets it wrong. So I flipped a coin 8 times and record the number of heads, heads being the number correct. And when I did that, I had actually 4. I suggest you do it too. Um, it's interesting to do. I don't know. I'm lame though. It's kind of fun. Sketch the dot plot, the clearly labeled dot plot here. So I had already drawn the dot plot, and you can get anywhere from 0 to 8 heads. Number of heads is the number of correct answers. So when I did it, I got 4. And of course, if we were doing this live, I would have everyone in class, I bring in a bunch of coins and we all do this and then record our findings. Now, we'll do that with the simulation in just a moment. I'll do it with a computer simulation. But first of all, before we do that, on the dot plot above, indicate where Sarah's actual observed result is. And we want to know what proportion of repetitions conducted so far did Sarah get 7 or more correct. So remember, Sarah, we know Sarah, I'll do her, mark hers in red. Sarah here, we know that she actually got 7. So we're curious how unusual it would be to get 7 or more extreme, more heads out of 8. Now, since we're not in person, what I'm going to do is I'm going to pause and then switch over to an applet so we can see this together and pretend that we're actually sitting there flipping coins. So here I am back at the applets. Usually we would do this strictly in for strategy number 2, but we're going to start with this for strategy number 1. I'm going to the one proportion applet. The probability of heads, so it's a fair coin, is 0.5. We're going to do 8 tosses, okay? And I'm going to show the animation. So what this is going to show me is I'm going to toss a coin 8 times, and I'm just going to do that one set, so it's representing one person. So here the coins are flipping, and this person got 5 heads and 3 tails. And of course, they would come up and record that on the board. I'm going to add, just to have it do 47 more to get to our class of 48. So what it's going to do is it's going to do this for everyone. And here's what it looks like for doing 48 total repetitions. We see it here. And we see here that most of the time you get 4, 5, 3, 4, 5, and then 6. Now there are some that got 7. So I'm going to pause again, take a moment, and I'm actually going to put this roughly in the notes. Now remember, it doesn't have to be exact. We just want to get an idea of what it looks like. So I did a quick sketch of what we saw. It's not exact, right? But this is just to give you an idea. So in what proportion of the reps conducted so far did Sarah get 7 or more correct? And she got it, in this case, 5 times out of the 48. Based on the dot plot, then, would it be surprising to get 7 out of 8 correct by just guessing? Well, it only happened 5 times, so I'd say, yeah, it looks like it would be relatively uncommon. It could definitely still happen, but it looks uncommon. Just because the vast majority of the observations are down here, are lower. Now, what if we go back to the applet, but this time, instead of just doing it for our class of 48, we actually do it for many, many more flip. So we really want to simulate this using hundreds, preferably thousands. We'd want to do it thousands of times. We would want to have lots and lots and lots of flips of the coins. It would be very tedious, time consuming. So now we're going to use that one proportion applet again. We're going to simulate 1,000 repetitions of Sarah choosing an answer randomly between 2 choices for 8 questions. And we're going to be curious how many get 7 or more correct answers. Here we are back at the applet. Remember, the number of tosses is not going to change because we're looking at 8 questions and she got 7 right. But instead of just the 48 that we did repetitions, we're going to do 1,000. I'm not going to show the animation this time because I don't want anyone to get sick here. And then I'm going to count, and it's going to show us what happened on the most recent result. And here we go now. We've got the number of heads. And if you look at this there, if you add it up and you could see the individual dots, there would be 1,000 dots in here. We're curious how extreme to get 7 would be. So let's count 7 or more. So as extreme or more extreme than 7. And that happened 0.0370. So quite a bit lower than what we had when we did it just for 48. So this is really the probability that you get 7 or more heads, and we get 0.0370. This proportion is called the p-value. It's always a number between 0 and 1 inclusive. It's a probability, and hence it's a proportion. We'll go back to, so this you can play with yourself. I highly suggest doing it. If I did, let's see, if I reset and I draw samples again, do you think I'm going to get exactly the same p-value, that same proportion? And the answer is no, but I did get pretty close to the same value. So back where we were, there's the information recorded. So looking at that last sentence, this proportion reported above G is called the p-value. It's a number between 0 and 1, inclusive, because it is a probability and hence a proportion. Now you may say, well, Sonia, this number is quite a bit smaller than 5 divided by 48. And it is. It's quite a bit smaller. Five times, honestly, I've never had it come up as 5. Usually it comes up as 2 or 3. And that's the 5 out of 48 is a little over 10%. That's a little bit of an unusual draw, but I wanted to show you, keep it in here, but to show you that yes, you can get unusual when you take these samples like this. You can get unusual or what unexpected results. So you want to be careful. Now remember, this was only 48. So we had 8, we flipped the coin 8 times, but we only did 48 repetitions of that. So I would say that while that's fine, what would be much better in terms of looking at the long run, because remember, we're always interested for probability being the long run result, it's much better using the computer simulation.